Bismillah ar-Rahman ar-Rahim, in the name of Allah, the most merciful, the most gracious. This is Ahmad Zahran speaking, and we are going today to start our very first lecture in relation to neuroanatomy and neurosurgery. And how about to start from where it all began? Welcome to our first lecture, as we are going to discuss CNS Embryology. Life starts with a very stressful competition, when millions and millions of sperms find themselves ejaculated in a uterus, a very weird place, and they are set to compete together in a very big race in order to reach the ovum. Only one sperm with all the best capabilities will be able to reach the ovum and perform fertilization. In fertilization, chromosomes of the sperm merge with the chromosomes of the ovum to form a unicellular zygote, the very first cell. This occurs in the fallopian tube. But everyone knows that pregnancy occurs in the uterus, not in the fallopian tube, so the fallopian tube has to get rid of this zygote. So it gradually helps the zygote to move towards the uterine cavity. But the zygote itself will not remain as one cell. As it moves from the fallopian tube to the uterus, it divides. One cell becomes two, two become four, four become eight, eight becomes 16, and so on, forming a lump of cells, what we call the morula. The cells in the morula are all the same. But as they go through the fallopian tube on their way to the endometrium of the uterus, they start discussing their future together. They know that they are going to be implanted in the endometrium, so they can obtain food and obtain nutrients from the endometrium of the uterus so that they can develop into the future fetus. So the morula will be developed into what we call a blastocyst, in which cells start to be differentiated, start to be specialized. Some cells will form the future embryo, and we will call them the embryoblast. And other cells will be specialized in obtaining nutrients from the endometrium, and we will call them the trophoblast. So now we have a blastocyst, which is composed of an embryoblast, which will develop into the future embryo, and the trophoblast, which will develop into the future placenta. As implantation occurs, each group of cells will continue performing its roles. Trophoblastic cells will merge with cells from the endometrium, forming the future placenta, but cells of the embryoblast will develop into a germinal disc. It starts with a single membrane, but then becomes bilaminar germinal discs, two layers of membranes in this germinal disc, one above and one below. The one above we will call it the epiblast, and one below we call it the hypoblast. What happens next is that a third layer is formed between the epiblast and the hypoblast. And now the germinal disc is composed of three layers. The epiblast will be now called the ectoderm, and the hypoblast will be now called the endoderm, and the layer that was formed in between will be now called the mesoderm, the layer in between. Ectoderm, mesoderm, and endoderm, this is what forms the germinal disc inside the blastocyst. Let me tell you a secret. You know what the endoderm will develop into? Cells of the endoderm will develop into the lining cells of the GIT, the gastrointestinal tract, as well as lining cells in the respiratory tract. The mesoderm, most of the cells of the mesoderm will develop into the skeletal system, the bones, and the muscles surrounding it. What about the ectoderm? Well, the ectoderm is supposed to be from outside, forming the skin that is covering the body. What? Now you've told me most of the GIT, the respiratory system, the musculoskeletal system, and the skin are formed from the endoderm, mesoderm, and ectoderm, but what about the CNS? Where does the CNS come from? What is the origin of the CNS? Big surprise. From the ectoderm. What? The ectoderm? Yes, the ectoderm gives origin to the skin as well as to the central nervous system. And this is a very interesting story. Let me tell you about it. When the cells of the ectoderm are staying together, most of them, they know that they are going to develop into the skin and they are living happily together. A few group of cells gather in the middle of the ectoderm and say that they are going to develop into the central nervous system, and they think that they are a bit higher in the level. They don't want to stay with this basic ectodermal cells that are going to develop into the normal skin. They are actually stimulated or teased by some structure in the mesoderm that is called the notochord. They feel that they are more special. That's why they're going to decide to leave, to detach from the ectoderm, and to go and find themselves a compound to live in. Let's say they are going to stay in the mesoderm. So, in the middle of the ectodermal layer, the cells that are going to be specialized as CNS, they gather together, forming what we call a neural plate. Then the cells of the neural plate start to dig inside the mesoderm, forming a neural groove. And then the cells of the neural plate on the neural groove try to come closer to each other to close this groove, forming what we call a neural tube. And it becomes totally detached from the ectoderm that will be now called the surface ectoderm, which will form the future skin. So the ectoderm now will be divided into two parts. The surface ectoderm, which is present in the ectodermal layer and will develop to the future skin, and the neural ectoderm, which has already detached from the surface ectoderm, and it lies inside the middle of the mesoderm as the neural tube. This process of the detachment of the neural plate and forming the neural groove and forming the neural tube and its detachment from the surface ectoderm, this process is called neurulation. After a successful neurulation and the formation of the neural tube that lies inside the mesoderm, the neural tube will continue its journey in order to develop into the central nervous system. And as we know, and we're going to know in the future episodes, the central nervous system is composed of the brain, the brainstem, the cerebellum, and the spinal cord. The cranial part of the neural tube will develop into the brain, and the caudal part of the neural tube will develop into the spinal cord, and what is in between lies in between, but let's discuss that in further details. This is how the neural tube looks like. Now it will develop into vesicles, what we call the brain vesicles. 3 primary brain vesicles will form in the cranial part of the neural tube. One in front, let's call it the forebrain or the prosencephalon or prosencephalon. One in the middle, let's call it midbrain or the mesencephalon or mesencephalon. And one behind, and simply we will call it the hindbrain or rhombencephalon or rhombencephalon. The journey continues. Each vesicle will develop. The prosencephalon, or the forebrain, will develop into two vesicles, telencephalon and diencephalon. The telencephalon, and I'm going to tell you that now, the telencephalon will develop into the future cerebrum. The cerebral hemispheres are actually arising from the telencephalon. What about the diencephalon? The diencephalon will develop into the future diencephalon, which is composed of the thalamus, hypothalamus, subthalamus, epithalamus, and metathalamus, each of which will have a special episode. What about the midbrain, or the mesencephalon? Where surprisingly the midbrain will stay as it is, midbrain. I will not develop to anything else. I will remain as midbrain forever, and it stays as midbrain, which is a part of the brainstem. What about the rhombencephalon, or the hindbrain? The rhombencephalon will develop into two vesicles. One will be called the metencephalon, and the other one is called the myelencephalon. The metencephalon will develop into the cerebellum and part of the brainstem, which is called the pons, while the myelencephalon will develop into another part of the brainstem, which is the medulla oblongata. And the remainder part of the neural tube will then develop the spinal cord. Now, we have a neural tube that has developed into brain vesicles, prosencephalon, mesencephalon, rhombencephalon. The prosencephalon will develop into the telencephalon and diencephalon. The telencephalon will form the cerebrum. The diencephalon will form the diencephalon, the thalamus, hypothalamus, metathalamus, epithalamus, and subthalamus. The mesencephalon, or the midbrain, will develop into the midbrain of the brainstem. The rhombencephalon will develop into the metencephalon, which will form the pons and cerebellum. The myelencephalon will form the medulla oblongata, and the remaining part of the neural tube will form the spinal cord. This is how the CNS is actually developed in a very simplified way. I hope you do understand it. Starting from the next lecture, we're going to go through neuroanatomy, and we are starting with brain anatomy in the next lecture. See you next lecture. This is Ahmad Zahran.